So far, we have been working on homogeneous systems, which are in the form of x hat is x prime is equal to ax, right? But when external forcings are applied, this will change into this form. X prime is equal to ax plus g of t. And here this term implies forcing, for example. Okay, and this guy can be written as x prime minus ax is equal to gx, right? And you can easily see that this is in the form of nonlinear, non-homogeneous ODEs, right? As we have seen in the second order ODE case. Okay, so usually this is general form for non-homogeneous system of ODEs. Right? Using a component form here, this can be written as x prime is ax plus by plus g1 of t, y prime is cx plus dy plus g2 of t. Alright? Okay. Now, how can you solve this problem? How can you solve non-homogeneous system of bodies? So, before we actually solve it, let's state a theorem, okay, which is quite similar to the second order ODE case. So, theorem here. The general solution of this non-homogeneous ODEs, system of ODEs, can be written as the sum of two solutions, right? And xh and xp. And here, this is a solution of this homogeneous system. And this is actually called particular solution, which satisfy the non-homogeneous system of ODEs. So, as we have seen in the second order case, if we can find any particular solution, we can get the general solution by adding homogeneous solution to this particular solution. Alright? And this is how we can find the general solution of the non-homogeneous ODEs. So, we are all experts in getting xh, the homogeneous solution. Let's consider how to obtain xp. There are actually three different methods of getting xp particular solution, and the first two methods are quite similar to the case of second order ODEs. As their name implies, they are called actually the method of undetermined coefficient and the method of variation parameters. Okay, and we'll consider these two cases in this lecture and leave the last one for the next lecture. All right. So let's first consider the undetermined coefficient method, right? So that is undetermined. So as you have seen in the second order ODE case, this method assumes the form of xp particular solution based on the form of gt. Alright, so we're actually solving here and we are trying to find out xp here, right? Particular solution. And here, as we have seen in the second order ODE case, we assume the form of xp based on the form of g of t. Okay? And this method only applies when a is constant coefficient. That means all the elements of a are constants, not a function of t. And when g of t has a specific form, for example, trigonometric, logarithmic, or polynomial functions, or their combinations. Alright? So this method is only applicable for those special cases. So let's consider the following example. So let's solve this problem. So this is example. So x prime is 2, 1, 1, 2 x plus cosine t and sine t. Right? This is non-homogeneous system of ODEs. So first, we need to solve the homogeneous part. Right? And we need to obtain xh. And since you guys know how to do it, I will write down the solution here. So if you solve it, xh is c1, 1, 1, e to the 3t plus c2, 1 minus 1, e to the t. This is xh. Now we need to find out xp. So the form of g of t is trigonometric functions, right? Just cosines and sines. So let's assume that xp is actually combination of sines and cosines. So we are dealing with this system of ODEs, so we need to write down the solution in a vector form, right? So we write the form of xp as a, this is vector here, right? A is a vector, cosine t plus another vector b, sine t. Okay? And let's write it down again here. These are the vectors. Okay? And now substitute xp into the given system of ODE, which is this guy. Alright? So if you plug it into the system of ODE, then you will get minus a sine t, because cosine is differentiated, plus b cosine t is equal to 2, 1, 1, 2. We have a cosine t plus b sine t plus cosine t and sine t. Okay? And you just collect the same terms together. Let's collect it based on the cosine and sines. So let's write it down. Cosine t. Then we've got b here, okay, from this term here. And we have a term from this guy. Right? So that is minus 2, 1, 1, 2 a. Right? Finally, we've got from this term here, right? So we only need cosine, right? So this becomes minus 1, 0. Okay, and the second term comes with all the terms with sine t. And what do you have? We have here, we have minus a, alright, and it comes with this guy, so we have minus 2, 1, 1, 2 b, alright, and finally we have a term from the last guy here, but we don't need sine, right? So we have 0, 1. Okay, this is 0. And if we write this guy in a component form, right? And then this, let's write it with a different color. So from this we can get B1 minus 2A1 minus A2 minus 1 is 0, and B2 minus A1 minus 2A2 is 0. Why? Because this equation should be satisfied for all t, right? For all t. So then these coefficients should be 0 for all t, right? So that means we have to satisfy this guy, and from the second term we can actually get minus A1 minus 2B1 minus B2 is equal to 0, minus A2 minus B1 minus 2B2 minus 1 is 0. Alright? So we have 4 coefficients, A1, A2, B1, B2, and 4 equations. So we can find out the solution. Okay? So, if you solve these, right, you can actually get A is equal to minus 1/5, 1, 1, and B is actually 1/5, 2 minus 3. Alright? Then the general solution is combination of xh and xp. So we can write the general solution x as c1 1 1 e to the 3t plus c2 1 minus 1 e to the t. Now comes the xp. So we found 2 coefficients, right, a and b, and we assume that the particular solution is in this form, right? So we plug a and b here, right? We can write down xp. So if we do that, then we will get minus 1/5, 1 1 cosine t plus 1/5, 2 minus 3 sine t. Right? So this is a general solution of the given system of ODE. And if the initial condition is given, then you can actually find out these values for C1 and C2. Okay? As we have done in the second order ODE case, we need to find out C1 and C2 after combining XH and XP, not before that, right? Because C1 and C2 would be different if we find C1 and C2 before we add these XP, right? So you should be careful about that. Okay, now let's look at the second method of solving non-homogeneous system of ODEs. That is actually called a method of variation of parameters. So variation of parameters. So this second method is more general than the first one. So it is applicable to the system with a variable coefficient, such as x prime here is equal to a of t x plus g of t. Okay? And here, the numbers in this matrix could be a function of t, functions of t. This method is based on the assumption that xp, the particular solution, is a variation of xh. That is also similar to what we have done in the second order case, right? So here we know that xh is c1 x1 plus c2 x2, right? And here these two are functions of t, right? But in this method, we assume that xp can be written by c1 t of t. So we change these two as a functions of t, right? This is the assumption of this method, plus c2 of t, x2 of t. And then this guy can be written as x1, x2, both of them are functions of t, and c1 and c2. And this is also functions of t, right? And what is it? This is actually fundamental matrix. Okay, using the notation of fundamental matrix, we can write this guy xt times c of t. Okay, and the next step is to substitute this guy into the given ODE, which is this, okay, and find the condition for C of t, right? So by substitution, we actually can get x prime c plus x c prime, okay, because both of them are functions of t. The right hand side becomes a of t here, right, and x and c plus g of t. And in the last lecture, we found that this fundamental matrix satisfies the differential equation, right? We know that x prime is equal to ax. That's the one of the properties that this fundamental matrix has, right? So because of this, we can cancel actually these two things, right? Okay, so we end up with x c prime is g of t. Okay, now from here we can actually get c prime of t is x of t inverse, right, g of t. And we can integrate, we can actually get c of t, right? This is integration of x t inverse g of t dt. And then what? Then we started with this guy, right? That is xp is given in this form, and we know what c of t is. So by putting that information there, so we can actually write the solution xp as, I will write it down again here, xc. So these are all functions of t, right? And we have x t inverse g of t dt, right? So this is actually xp, right? Formula for xp. Now let's actually solve the same problem, okay, with this method. This example. And here again, x prime is 2, 1, 1, 2, x plus cosine t sine t. Alright, and you know how to get the fundamental matrix, right? So if you find that, you will get this guy. E to the 3t, e to the t, e to the 3t, minus e to the t. Okay, and we need to invert this guy, right? So this becomes minus 1 over AD minus BC is minus 2 e to the 4t. We have minus e to the t, e to the 3t, and minus e to the t, and minus e to the 3t. Okay, and you multiply this out, then you will get what? You will get 1/2, and you get e to the minus 3t, e to the minus 3t, t, and e to the minus t. Okay, all right. Then what? Then we can actually get XP, okay, using this one, right? Where we know all the information in this figure, right? So let's actually multiply G of t right away here. So let's apply G here. That is what? Cosine t and sine t. Okay? Then you will get 1/2 e to the minus 3t cosine t plus sine t, and you will get e to the minus t cosine t minus sine t. Okay, and now you need to integrate this guy, right? And then multiply x of t to that equation. Okay, then you will see that you will get the same answer as before. Right? So I'm not going to go through all the calculation, but leave it for your exercise. Alright? Okay, so that's it.